Hello friends! Hope you had nice holidays. But holidays are over and it's time we get back to expanding our knowledge. So today we will learn how to hook DirectX 11, more specifically the present method. I have chosen Crysis 2 as a target. Since version 1.9 it supports both DirectX 9 and DirectX 11. With DX11 enabled and after injecting our DLL, the ImGui demo window pops up, confirming that the hook worked. Let's get started right after the intro.
You know what I like a lot more than materialistic things? Knowledge.
That's a hacking group we've been reporting on that's claimed responsibility for recent attacks.
Before jumping into the code, we gotta cover some basics. But before that, I gotta give some credits. First, credits to RDBO with his well-known ImGui DirectX 11 Kiro hook repo. Nice project, which I definitely copied. However, I did add a small but important thing we will cover later on. Second, of course, credits to Repsol for his Kiro repo, which includes hooks not only for DX11 but also many other graphics APIs. I used but changed the DX11 relevant parts to show and explain what they do. Now to covering the theory. No worries, I'll keep it short. In DX11 everything is rendered to the back buffer. After that is done, the preset function is called presenting the back buffer to the screen. By hooking that present function, we can render our own things inside the Detour and then call the original present function. To do so, we obviously need the address of that present function. The swap chain COM interface exposes it, which leads us to the same approach we already used with DX9, the so-called dummy interface method. By creating our own swap chain, we can get its vtable and from there the function pointer. In case this isn't clear, this is just one way of finding the function. We could also use pattern scanning, for instance. Now let's jump into the code. We call create device and swap chain, which takes 8 in parameters to create the swap chain COM interface. First, a pointer to the video adapter. By setting it null, we use the default. Second, the driver type. By passing type hardware, we say the Direct 3D feature will be implemented by the GPU. Maybe you wonder if we could use another driver type here. After all, we are only creating a dummy. The answer is yes. We could, for example, also use type null. Just make sure that the parameters make sense together. For example, the next parameter being the software. This one should be null unless we, for whatever reason, passed type software as second parameter. Anyways, let's keep it simple. Fourth parameter, the flags. No need to overcomplicate things, just pass 0. Next up, a pointer to the feature levels. Kiro passes these two. I also tested just passing feature level 11, as well as passing null instead. All tests succeeded. So I guess this doesn't matter too much. Next, the amount of feature levels. Make sure this matches with the length of the array. When passing null instead of the array pointer, setting this value 0 works. Then we have the SDK version. The documentation tells us to use D3, D11 SDK version, so that's what we do. Last but definitely not least, in parameter is the swap chain description. Since we want to create a swap chain, we have to pass this parameter. If we only wanted the device, we could pass null instead. This parameter is a struct and it contains a lot of variables. I will only briefly cover the ones we need. The buffer count is the number of back buffers. We set this to 1 for double buffering, but we could also set it to 2 for triple buffering, for instance. The format describes the format of the display. Here it is important to pick a value which is supported. You can use DirectX Caps Viewer if you want to go dark.
Bravo 6. Going dark.
Or just use this one, which should work for pretty much any GPU. The buffer usage specifies what we want to use the buffer for. In our case, I believe the only valid value is render target output. The output window should be the game window. Here I use get foreground window to get that handle. This might be unsafe, but it never gave me any trouble. Sample desc describes the multi-sampling. We have to set the count to something. We could also set the quality, but we don't have to. Windowed is set to true as advised by the documentation. And by setting swap effect to discard, we let the display driver select the most efficient presentation for the swap chain. Finally, we have all the in parameters. Now we need the pointer to store the created swap chain end device. Simple enough. If the function succeeds, it returns as OK. In that case, we can proceed to getting the vtable pointer. Quick explanation on how this works. The swap chain variable is a pointer to the swap chain. The vtable pointer is at the very beginning of the swap chain. So to get the vtable pointer, we have to dereference once. In C++, an array is the same thing as a pointer to the first item in the array. And by accessing one entry of the array, we dereference another time, which means we follow the pointer at the first location of the swap chain and end up inside the vtable at whatever location we chose. At that location is the pointer to the function. Let me show you this again by example. First, we copied the values for the swap chain pointer, the vtable pointer, and the present function pointer. In Cheat Engine, let's start with the swap chain pointer. By dereferencing, we get the value at that location and store it as our vtable pointer. Again, this works because the vtable pointer is the first thing stored in the swap chain instance. Then, by using this pointer like an array, we follow the vtable pointer and count up to 8. And there it is, the present function pointer. We can copy that one and have a look at the function. Well, it is indeed the start of a function. We could now create a signature or check back in later to see what minhook does. We used index 8, but why? Let's have a look at the definition of the swap chain. Here we see the definition of the vtable. Let's count those entries until we get to the present method. It is the 9th method. Because the first function is at index 0, the 9th function is of course at index 8. Not only do we have the correct index now, but we can see also a bunch of other functions which we could hook if we wanted to. And we can see the calling convention. It is a STT call with 3 parameters. The dis pointer, so the swap chain pointer itself, and 2 uint variables. Here we have the typedef of exactly that function and 2 pointers. One for the original function pointer, which is where we just stored the pointer we got, and one for the function after the hook. I already made a video on hooking with minhook, so I won't explain it again here. In case you are confused, go ahead and watch that video linked above. And here is the detour function. Of course, definition and parameters have to be the same as the original function. Last thing inside the function is calling the original present function, and before that we can do all the rendering we like. All I do here is initialize ImGui and then use it to show the demo window. I won't cover this in detail because that's not point of this video. If you want a video on how to use ImGui, let me know. Inside the main function, we first get the present function pointer, then we use minhook to hook that function, passing a pointer to store the detoured function, the detour function itself, and the function pointer we just obtained. We loop until numpad 1 is pressed, at which point it is time to unload everything. And here is where some people have trouble. Most of this is covered by RDBO's repo, but this one line is definitely missing. We gotta restore the winproc callback function. Of course, this is only relevant to you if you decide to use ImGui. And that's it for today. As always, thank you very much for watching, join the Discord, subscribe for more hacking videos. Until next time friends, talk to you soon.